Alright, my talk is about MySQL replication. So what is it? It's a replacement for MySQL's built-in replication. Why would I want to do this? First, I'm going to have to give you a bit of an explanation of what replication is. It's synchronizing data between multiple databases. So you've got one database on the left. Any changes on database 1, go to database 2. Any changes on database 2, go to database 1. Why would we want to do this? I'll show you some examples. Redundancy. So we've got a database and we've got lots of clients. Problem is, let's say the database catches on fire.
The clients catch on fire as well.
Well, there goes your system. If we had replicated to hot standby, clients could then be moved, like so.
Primary's hot.
Well, we don't care now. Our clients are good. Another example, performance. So let's say you've got a database and you're happy, you've got a client connecting, another client, you know, all is well. All of a sudden, too many clients start to kill the database. You start to kill the database, you got a bad system. So if we had replicated for scale out, load would be spread. So what we have is two databases in replication, and each client, we scale them out, connecting to the different databases. And if you look, those are the same number of clients, but the load is spread, so the system's fine. So, why replicate? Because it's nice. Compared to having a single database. So, how does it work? In particular, how does MySQL replication work? The built-in MySQL replication. We've got a database on the top, and we call it the master database. Clients connect to the master, and that's where all the writes happen. So, we want to replicate the data on the master to the slave. A client comes in, connects to the master, does some manipulation, let's say an insert. The insert text along with the insert query along with some metadata gets written to a thing called the bin log. Now that's just a plain file. The slave connects to the master, reads the bin log and copies it locally to a file called a relay log. That then reads the query text in the relay log and executes the SQL into its own database. So, the cool thing is about MySQL's replication is that each slave can be its own master to other slaves. So, you can have a master giving a data feed to all the different slaves, and you can turn that master into a slave, that slave into a master and then replicate out, and then that slave to a master and replicate out. This works fine, but slaves can only have a single master. If you look at it again, now if we want to do writes, we only do the writes to the master and the slave just gets a copy of whatever happened on the master. Does that all make sense? Yep. Okay, so what? That means that there are no multiple masters. So we have a slave, we've got multiple masters, multiple writes. MySQL can't do that. Why not? Don't ask me, I wasn't there. It's a design decision. Yeah, I don't know. But we can emulate multiple masters. To do this, we have to set up a ring topology. What does that mean? Each slave is a master to another slave. So, like before. But then that slave turns into a master, and the slave replicates off that. That slave turns into a master, replicates off that. That slave turns into a master, replicates into that. Looks nice. And then we can also hang slaves off, you know, since each slave can be its own master to a different slave, we can hang stuff. Yes?
How does the ring know to stop? When it gets around to the number
give me a couple of slides.
Sorry.
So, it all works well. How does this achieve multiple master replication? I'll get to that in a minute. So by having each master write all queries to its bin log, including the queries that it replicated from its master. Alright, I'm rambling. Alright, queries that are passed around the ring, kind of like pass parcel. So we've got 4 databases, I write a query, you replicate it. You're also doing queries from your clients, you know, you bin log it passed along. Okay, that all makes sense so far? Yeah? Okay. So, why is this a problem? When the ring breaks, okay, so does everything else. And recovery is hard. Why? Here's your answer. Infinite loops. What do you mean? Each master is responsible for its own termination of queries. What do I mean by that? Going around the ring, in other words, queries don't replicate infinitely because a master won't relay its own queries twice. So if you look back here, query goes around, so the top left replicates and all goes around the circle. Once it pulls off its own master, its own query, it looks at the query and says, oh, this was originally mine, I'm not going to pass this on again.
How does it know it was its own query?
Oh, laser pointer. How does, okay, so each query, like I said before, okay, so, yeah, you got all that? Yeah? Okay, how does it know? The query text also has metadata, and the metadata has, so each master has a server ID, and so the server ID is carried along with the queries.
Okay.
You may come to this later, but if it takes some time to go around the ring,
Yep.
what happens if another conflicting query
I'll get to that later. So, what happens if a database goes down? We recover by connecting the links and restarting replication. What do I mean? We do this. Okay. So, like I said before, OpenOffice doesn't do exactly what I want. That arrow is supposed to just be pointing up. Okay. So, let's pretend. Okay, so what do I mean? Okay, hang on. Who is responsible for the terminating queries? The failed database. Alright? So, what do I mean? If there are queries from the failed database that are still in the replication loop that haven't yet terminated, so let's say query from there was here, right? And then that gets replicated there, there's nothing terminating there, it goes back to there. Ah! Okay, infinite queries, infinite replication. And the problem is each time you bin log that query, it multiplies. So yeah, you do get infinite replication. So, how can I achieve multiple master replication that is fault tolerant and easy to recover from? MySQL replication. It's a replacement for MySQL's built-in replication. It's based on a client-server model. Each master runs a server. So here's the old diagram. A master so we all stopped the built-in replication. A master turns into a server, as you see there. Each slave runs the client, and the client can run multiple instances of the client, one for each server. Think peer-to-peer. So it'll all make sense in a sec. So, as we can see, the client connects to the server and pulls. So there's no more parser-parcel, it's direct. Make sense? Yeah? Okay. And if something breaks, it's only the peer that's affected, since there's no parser-parcel. So, if the failed database does recover, we bring it back up, we restart from where it left off. All good. Otherwise, if we can't, let's say it did catch on fire, we just fail it out. And we can take our time rebuilding. It was redundant anyway, right? Yeah? Yeah. Oh, yeah, no infinite loops. Okay, why not? Since okay, I've explained all this. No intermediate can break, there's more. Okay, relocation. So, MySQL colon replication also does relocation. What does that mean? So instead of connecting directly to the master, like that previous diagram, the client connects to a local relay. And if the relay doesn't have the queries that we're actually interested in, it will go off and get it for us. What do I mean by that? An example. So multiple clients. Let's say we've got multiple clients in data center A. And each client connects to a particular server in another data center. Let's say on the other side of the world. Each download the same query. What a waste, right? In bandwidth and in server load. Because don't forget, the server that each of these clients are connecting to has to do some work to pull it out of the bin log and stream it across. So there's processing time and there's network time. So instead, we each connect the clients to the local relay, and now only the relay connects to the server. So saves bandwidth and saves server load. So, is it on CPAN? I kept saying I was going to put it on CPAN. It's almost ready. Okay, the client server bit is actually working, and it works. It's in production and it's going good. Side note, it did die once, but that's because someone ran a query that they ran a load data in file, which currently is not supported. But when I get time, I'll add it. Yeah, so I just need to do the documentation for the client.
So it's never going to get there.
No. That's why, this is why I wanted to give the talk, because I'm going to use the talk as the documentation. Yeah, because if you just write documentation, who wants to do that?
Exactly.
So, after I do that, which now I've got the talk, I'll write the documentation, I'll put it on CPAN. About the relay stuff, it's nearly complete. I'm almost there, the 90% thing. 90%'s done, I've just got the next 90% to go. Yeah, I just need to finish it. Look, the code's done. Yeah, the code's done. I just need a couple more test harnesses just to be sure. I don't want to release something into people's. I know you won't put it straight into production, but at least testing it. There's no point testing stuff that doesn't work.
So you didn't write the test first then?
No. I'm in conjunction. Yeah, I'm testing my yeah. Yep, and I need to write the documentation for that. So FAQs. What happens with collision? Your question. So when two databases update the same record, it's a race condition, especially if there's long lag. Unfortunately, you either can solve it at the application layer, and what do I mean by that? Stuff like if, let's say you've got a login system, and let's say you've got a web page and people can create users on the web page, and they can choose their own username. And the web interface is connected to different databases, right? Because now they're all replicating. We can have as many web interfaces as we want and many databases as we want. We don't care. But if one person logs into, if two people go on these two different web servers, connect to the different databases, create the same user ID, it will work. It's only later when they go to replicate that will get a duplicate key constraint, or even worse. Actually, no, there's probably nothing worse. So something like that, you need to use a broker. What do I mean by that? Run something separate that is canonical. Each web interface talks to the broker and says, am I allowed to create this user ID? But that's not part of the replication. That's, again, high level. Or shard writes. What do I mean by that? Some tables, let's say only these machines are allowed to write records with names starting with W, or split your data so you don't get.
Explain what a shard is first.
Okay, a shard is you got your data, you separate your data into kind of like radix.
You can sort your data by columns or by rows or by segments or by...
Yeah, it's segmenting your data so...
Physically putting data onto separate machines.
Yeah.
So the queries run faster.
Yeah.
For those types of queries.
Yeah.
So usually the shard matches the access pattern.
Yeah. Yeah. Questions?